Hello and welcome to another video in the series on the flat pulley assembly. In this video I'm going to look at creating a 2D assembly drawing of the completed assembly, including a sectional view and a bill of materials. So to create a new 2D drawing from any existing assembly or part, we just go up to the top here to the new document and create or click on make new drawing from part or assembly. So it'll prompt you first of all what type of what size of sheet and what kind of template you want to use. So for this assembly I'm going to use an A3 ISO. It's in landscape and has a title block associated with that. There are more formats here if you uncheck the box for standard formats, but for our purposes here I'm going to use the A3 ISO sheet and click OK. Okay, so that puts in an A3 sheet in landscape with a title block already associated with it. Now you'll see on the right here you have a view palette with your front view, right view, top view. These will be associated with the view from the front plane, right plane, top plane of your assembly. Now Solidworks will default to a third angle projection scheme. So the first thing I do before I go putting in any drawing views is I'm going to change that to a first angle projection. So on the left hand side here, if you right click on sheet 1 and go to the sheet properties, we can change the name of the sheet, the scale of the sheet, the template and so on. But we can also change here the type of projection. So as I said, defaults to third angle. I'm going to change that to first angle and apply changes. Now what I want to do is to import some views of my assembly into this sheet. So on the tabs up here at the top I have my drawing tab. I'm going to import a single view of this and then project other views from that. There is a standard 3 view that you can put in over here. We'll put a plan elevation end view. I prefer to do that manually, so I'm going to click on model view here. Select from my open documents the flat pulley assembly. So select the flat pulley assembly and click on next here. Okay, so it's looking for a model view of my flat pulley assembly. So I'm going to click the front view here. So that should look in at what was the front view, the front plane of my finished assembly here. I also have some other options about the display style to put it in. I'll just put it in as the default style first of all, and we can modify that afterwards if we need. Okay, so you'll see that has put in a single view of the front view of my assembly. It will default then that it's automatically going to project another view off of that front elevation. Okay, so I'm going to project a view over here to an end view over here to the left hand side. So this would be a view looking from the right hand side but shown on the left hand side as in first angle projection. I'll also project a view, a plan view, which will be shown down below. So the view from above displayed down below here. So that's your standard plan elevation end view in the first angle projection scheme. Now you can also project isometric views off like this, but I'm not going to do that as a projection. I'm going to do it as a separate sort of pictorial view, let's say. Okay, so this first view that went in here is kind of the important one. So the front elevation or whatever you've put in first and that the other views are projected off, you'll see if I move that around, the other two views move with it. So that they're always directly below or directly across from that first view that went in. So this is considered the parent view, and these would be considered children view projected off it. So I can individually change display styles for, say, one of the child views, and none of the other ones will change. But if I change the display style of the original one that went in, the parent view for example, so if I make hidden detail available, you see this one here has hidden detail available as well. And this one hasn't changed because I manually overrode that. So I'm going to change that to use the parent style. Okay, so I have my 3 views in here with hidden lines visible. I also maybe want to create a sectional view as well. So I want a sectional view of the front elevation here with so that I can see the hidden detail inside here where the spindle part interacts with the bracket and let's say see the internal views of the holes through the flat pulley itself, that kind of thing. So to create a sectional view within Solidworks, again in the drawing tab up here at the top, we can project views, we can create auxiliary views, or we have a section view here. So when creating a section view, essentially we're going to drop a cutting plane down through one of our views here, and a view will be created of what you would see looking perpendicular to that plane. So I can do it like on any one of those views. We get some options here. Do we want a vertical cutting line, a horizontal cutting line, an auxiliary or kind of angled view, or do we want an aligned view, which maybe if we want a cutting plane coming up through one of these holes and then going off at 120 degrees to one of the other holes, we could use an aligned section. In our case, we just want a simple vertical cutting plane. I'm going to put the cutting plane through this view here and have it projected over here on the right hand side then. We could also say put a horizontal cut through this view here, and then maybe show that section above or below that point. It'll be projected in a straight line from that cutting plane, so perpendicular to that cutting plane. So as I said, I'm going to do a vertical line down through the center of this end view over here, and click OK then. So I can click OK here or here. Now that's going to show the view looking the direction of the arrows pointed here. I can swap the direction so that it's looking from the other side if I prefer. In this case, for this part, it won't make any difference because it's symmetrical. So the dialog that has popped up here then is what's called the section scope. The section scope allows you to choose items to include or exclude from the cutting plane. So by default, it's going to put a cutting plane down through the part here. By default, every single item, every part that intersects with that cutting plane will get cut in half for the sectional view. That may be what you want for a simple part, that might be fine. In the case of an assembly here, where we have, let's say, fasteners, for example, so your nuts, bolts and washers, by convention, certain parts such as nuts, bolts, washers, but also shafts and pins, split pins, things like that. By convention, certain things are not usually included in a sectional view, or they're not usually cut in a sectional view rather. So what I need to do here in this dialog box is to pick certain parts that I want to exclude from the sectional view. Now as it happens, the nuts and bolts are not passing through the section plane anyway, but if there were, I'd highlight them here. What I do want to select is I want to select the split pin, and I need to click on it in the view that I'm putting the section plane in. So I'll select the split pin and also the what I've called this pulley spindle, the shaft running through the center of it here. Okay, so I need to select them in these views, in this view here. Sometimes that can be a little difficult if it's in behind something, if the part you're looking to select is in behind something. What you can do in that case is you can right click and go select other, and it'll give you a list of all of the part files that are directly behind where your mouse is pointing. Okay, but in my case, I can simply select the pulley spindle and the split pin from that view. Okay, as I said, if there was any fasteners or maybe bearings or shafts, maybe gears, those type of features typically wouldn't be cut in a sectional view. Okay, so you see here that has created a sectional front elevation for me here, and I'm going to project that over here to the right hand side somewhere. Okay, so you should be able to see from this view that, for example, the pulley part itself has been cut, and it has hatching lines associated with the material, so it's some type of polymer, nylon in this case I think. But the pulley, for example, or the pulley shaft or pulley spindle here has not been cut, so you can see that has been shown. It's been shown in full, not cut. Likewise, the split pin here is not sectioned, not cut into section. Okay. Now I can move that part around to wherever suits and respace my views as needed. Okay, so that's the basics of putting in a section. You can get more involved in it, obviously. Now, so as I said, the hatching then, Solidworks will put in some hatching by default into the part, and it's based typically on the materials that you have assigned in the modeling. So, for example, my pulley base here, if I look at the material, is down as plain carbon steel. The pulley spindle is down as alloy steel, and the pulley wheel itself then is down as nylon 6. So the type of hatching that goes in is based on what your material selection for that part is. So steel here, for example, is 45 degrees, and for steel you have two hatch lines close together and a slightly wider gap, and then another 2 hatch lines. You can modify those, so if I click on that sectional view, click on the hatched area, it pops up here on the left hand side with the area hatch fill. So it has selected for these a hatch pattern based on the material. If I want to manually change that, I can uncheck the box for material crosshatch. So I can manually select a particular type of material hatching. I can also modify the scale of it, so if I wanted to make that make the hatch pattern larger, I decrease the number here, or if I want to make it smaller, I can increase the number here. I'm going to leave that as default for now. The other thing that you may want to do, depending on how your various parts in your assembly fit together, is you might want to modify the angle that they're at. So typically where 2 parts are meeting, 2 parts of the same material, so the steel base and the steel bracket here, for example, you typically want the hatch patterns to be going in opposite directions. So plus 45 degrees, minus 45 degrees. You can modify that here with the hatch pattern angle. So if I wanted to rotate this one here by 90 degrees, I can type in 90 degrees here, and it rotates it that way. You may notice from this view here that Solidworks will attempt to have 2 neighbouring hatched areas at different angles. Sometimes it does a good job at that, sometimes you have to manually tweak the angles that the hatch patterns are at. Okay, so I think in this case it's done a reasonably good job. I'll leave that as the default there. Okay. One other thing that might be worth noting is if I want to go back in later and modify the section scope on this part, let's say for example I forgot to exclude the pulley spindle part here, or the split pin from the section, I can right click on the sectional view and go to properties, and in the drawing view properties I can go to a tab here for section scope, and I can add or remove excluded components from that sectional view. Okay, so that's the sectional view completed. The other thing that I might like to have in on this 2D assembly drawing is I'd like to have a bill of materials detailing what each of the different parts are in the assembly and how they sit together. So to input a bill of materials, you go to the ribbon at the top, go to the annotation tab, and over towards the right of the annotation tab you can put in a kind of a manual general table, a whole table, or a bill of materials table is a common one. So the bill of material table asks me to specify a drawing view, select a drawing view to specify the model. So I want to take this view here of my assembly, and what it'll do is it'll take all of the parts in that assembly and create a table of them. Okay. You can have different templates for the bill of materials. I'm going to just use the standard one here, showing parts only. Okay, and if I click OK at that, you'll see it automatically generates a table for me of my 4 parts that I've created manually, but also then the nut, the washer, the nut, the bolt, and the split pin. Now if I move that around, it'll kind of snap to the format of the sheet as well. So I'm going to move it down till it snaps to the top of the title block, and over to the right you'll see it snap to the border, and left click then to place it. Okay, so what that has done is it's created an auto-generated table with numbered parts. So item number 3 here is the pulley spindle, and that has a quantity of 1. Item number 5 is the washer, and there's 8 washers in total included in that assembly. Okay, now to indicate on your model or on your assembly drawing which one of these parts is which, what you can do is you can include a balloon reference here. So if I, on my annotation tab, come over here to balloon, you see yeah, I'll just place one in, for example. So I will put say a balloon on the pulley part here. What it does is it places a leader essentially with a numerical reference. So number 4 in this case, if I come down to my bill of materials, number 4 is the pulley wheel, and let's say the bracket here is number 2. The spindle here is number 3, and the base here is number 1. Now you can see as I move it around, you'll get an indication when you're in line with previous balloons. So I'm going to put that here, number 1. Okay, so that'll allow you to place identifiers on the model directly related to the item numbers on your bill of material. Okay, so that's more or less it. As I said earlier, I might put in a pictorial view. The overall aim of this 2D drawing for your assembly is to show the reader how the part fits together. So what type of views you put into your assembly drawing will depend really on what gives the most information, the most clarity to the person who's reading your drawings. So if there's enough information in these views here, then that might suffice. If it's going to be more useful to the reader to have a kind of a 3D representation of the part, then we can put that in as well. So if we go back here to the drawing tab, we can put in another model view. So this one will be an independent, it won't be projected from one of the other views. Put in a model view of the flat pulley assembly, click on next here, and this time I'm going to put in an isometric view with display style here of shaded with edges. So that puts in kind of the standard isometric view of the part, and as I said, that's independent. You can move that around. It's not necessarily projected from your original parent view that went in here. Okay, and this will be optional, as I said. It's if this lends more clarity to the reader, then you might include it. Okay, so that's more or less completed. The other thing that you may sometimes see on assembly drawings is you may see some dimensions. Now, typically you wouldn't dimension parts, so I wouldn't put in a diameter 12 on this spindle, for example, because there will be a separate drawing of that spindle on its own with the detailed dimensions for that. But what you may see on the assembly view is some overall dimensions of the finished assembly as it's all fit together. Or there may be some other dimensions that only make sense in the context of an assembly as well, that you couldn't put on an individual part, for example. So you can, as I said, you can put in dimensions there. So if you go to the annotations tab, we can use the smart dimension tool. Let's say we'll give this the overall height from the bottom of the base to the top of the pulley, for example. Or you could also maybe put in from the bottom of the base to the center line of that spindle. So that's something that you wouldn't get from any of the individual part drawings, but you could get that from the assembly view here. So I can put in a dimension from the bottom of the base plate to the top of the part over here, top of the pulley wheel. So that's 105 millimeters there. What you will sometimes see, if that's kind of not a functional dimension of one of the individual parts, sometimes you may wish to put that 105 millimeters in brackets. So you can come down here to dimension text and you can override the automatic dimension. So this dim here is the calculated dimension of 105 millimeters. You may wish in some cases to put that in brackets, so you can simply type a set of brackets around that there with 105 millimeters. Like as I said, I might want to put a dimension from the bottom of the base plate to the center line of the spindle. So I want to dimension to the midpoint of that line there. Now my smart dimension tool is not picking up on the midpoint of this line here, so what I could do in this circumstance is I could put in a center line there and then dimension through the center line. So if I go to the drawing tab, no, the annotation tab, excuse me, I can put in a center line over here. So center lines and center marks we've talked about in the context of individual parts before. But on my assembly here I can put in a center line between here and here, let's say. That puts in a center line, and I can manually extend that center line out a little like that, and then I can dimension from the bottom of the part here to that center line. So 65 millimeters, and again I'm going to put in brackets on that dimension there. So that would be kind of just for information purposes for the whoever's assembling this part together, for example. So you wouldn't manufacture to those dimensions. They are going to be a function of the overall finished dimensions of the base part plus the bracket part plus the to an extent the spindle part maybe. So they're a combination of the dimensions of the other parts together. So that dimension there is just in for information purposes really. You may also want then, let's say, a dimension on the overall width of the base and the overall length of the base possibly as well. Okay, so I'll put a dimension here. This here being the overall width of the assembly as a whole. So 110 millimeters, and maybe this 105 here is the overall height of the assembly, and you might maybe put a dimension on the overall width, but I think that's probably sufficient there. Okay, so I think that is more or less complete. It's gone on a bit long in this video here now, so I'll go through the title block in a future video. So I'm going to do another video now on doing a 2D drawing of an individual part, and in that video I'll talk more about the title block and putting in parameters here, so your name or student number, the overall title for the project, and then the individual title for the drawing, say the part name, that kind of thing. Okay, so I'm going to stop the video at that there, and I'll continue with another video then on drawing a drawing of an individual part.